Math is really its own language. And just like any language, it has rules, a kind of universal grammar. It's the reason an equation means the exact same thing whether you're in Tokyo or Toronto. So today, we're going to unpack the fundamental rules that make this whole language of math and physics actually work for everyone, everywhere.
So here's what we're going to do. First, we'll talk about why we even need these rules in the first place. Then, we'll get into the order for solving problems forwards, learn the trick to working backward, actually use it to find a missing number, and then we'll tie it all together and see why it matters in the real world.
Okay, before we dive in, just take a look at this problem. Seriously, what do you think the answer is? Because depending on how you tackle it, you might get 40 or you might get 16. See the problem? This is exactly why we need a clear set of rules. We'll come back to the answer in just a bit. That little moment of confusion you just felt, that's precisely what math's grammar is designed to get rid of. I mean, without a standard order of operations, trying to build a bridge or code a video game would be total chaos. There has to be one and only one correct way to read the sentence. And this quote from Math with Mr. J just hits the nail on the head. The goal is super simple. Get everyone on the same page. It's a universal standard that cuts through all the confusion, and that allows for real collaboration and scientific progress. So how do we read that story the right way? Well, the answer is the order of operations. It's basically a set of instructions we follow, step by step, to get from a messy problem to its one single correct answer. And the key to remembering this order is a really simple acronym, PEMDAS. You've probably heard it before, maybe something like, please excuse my dear Aunt Sally, but we're about to make it totally clear. Just think of PEMDAS as your roadmap for any equation you'll ever see. So let's break it down. P is for parentheses. Anything inside those little brackets gets solved first, top priority. E is for exponents, they're next up. Then we have the duo of multiplication and division, and finally, the last pair, addition and subtraction. Okay, now this is really, really important. This right here is where most people get tripped up. Think of multiplication and division as a team. They're on the same level, same priority. And it's the same deal with addition and subtraction. They're a team too. So if you see them together in a problem, you don't just pick one. Nope, you just work straight through from left to right. That's the key. All right, theory is one thing, but let's actually make this real. We're going to walk through an example from one of our sources and see how PEMDAS actually works out in the wild.
So here's our problem. 16 minus 5 times 3 plus 12. We've got subtraction, multiplication, and addition all in there. So, according to our PEMDAS rules, what do we do first?
Exactly, the multiplication. So the very first thing we do is solve 5 times 3, which is 15. Now our problem is a little simpler. It's 16 minus 15 plus 12.
Now for that crucial part we just talked about. We have subtraction and addition, and remember, they're on the same team, so we just work from left to right. Subtraction comes first, so we do 16 minus 15, which gives us 1. And look at that, we're left with one easy step. 1 plus 12 is 13. And there it is, our one and only correct answer. Oh, and by the way, remember that first problem we looked at? The answer was 16. Did you get it right? So that's awesome. We now know how to follow the rules and go forward. But, in algebra and physics, a lot of the time you already know the answer, but you're missing one of the pieces. So how do you work backward to figure out what that is?
Well, this is where a cool concept called inverse operations comes into play. If PEMDAS is how you tie a complicated mathematical knot, then inverse operations are how you carefully untie it to find what's hidden inside.
Inverse operations are really just pairs of functions that cancel each other out. Their whole job is to let us peel away all the other numbers in an equation so we can get that one unknown value, or x, all by itself. And the pairs themselves are pretty straightforward, right? The inverse, or the opposite, of adding is subtracting, and the inverse of multiplying is dividing, and it works the other way around too. These are the exact tools we need to retrace our steps. Okay, let's put this into practice. We're going to solve for a real unknown right now. We'll find the value of x by using these inverse operations in a really specific order.
All right, here's our mission. Solve this equation. 10x plus 3 equals negative 7. To find x, we've got to get it completely alone on one side of that equal sign. And to do that, we're going to unwrap the equation by using PEMDAS, but in reverse.
So first things first, we undo the addition. The inverse of adding 3 is subtracting 3. But here's the golden rule of algebra. Whatever you do to one side, you have to do to the other to keep things balanced. So we subtract 3 from both sides, which leaves us with 10x equals negative 10.
We are so close. Now we just have to undo the multiplication. The inverse of multiplying by 10 is dividing by 10. We do that to both sides, and we get our answer. X equals negative 1. See? We've untied the knot and found our missing piece.
So, why did we just go through all of that? Well, because these aren't just some abstract rules you learn for a math test. This is the logic, the operating system that powers our entire modern world.
I mean, every single time a physicist calculates the force needed to launch a rocket or a programmer writes code for your favorite app, they are using this exact logic, this step-by-step process. It's the absolute bedrock of problem solving in engineering, computer science, finance, you name it. It is literally everywhere. So the next time you see an equation, try not to just see numbers and symbols. See a language, one with a universal grammar. A grammar that's running the code on your phone, mapping out the trajectory of a rocket, and even describing the physics of a black hole. So the question is, what part of the world will you use it to understand?